In this video, we're going to be talking about the performance-based rooftop unit family. This rooftop unit family builds upon all the previous families that we've discussed. It was a derivative of the mechanical equipment configurator and built upon some of the auto sizing and coil calculations that were first used in the VAV box family. Now, even though this family isn't an auto sizing family, it does include a lot of calculations and has a lot of information in the performance tables. So this family should make your life better, is what I'm thinking. Here it is in the browser list. This is based upon Carrier's equipment, their LC series. What we've been able to do with the mechanical equipment configurator is combine all the different tonnages for a given manufacturer into one nice little compact family. So, previous issues where, duct connectors were oriented differently, or maybe horizontal connections on a unit, all that has been able to be combined into one family. Let's just place the family and then let's talk about it. All right, we've got our clearance arms in here. This is like all the other mechanical equipment. It's not a face-based family. So this family here, you can offset up or down to your heart's content. So if structure is sloping and you're placing this on a level, you don't have to make a whole bunch of reference planes because the roof is at that given elevation at that spot. You can just adjust the offset. So lots that we could talk about with this family. First off is the fact that all of these types are combined into one family. So like if we went up to a 7.5 ton family, you'll see everything flexes. If we went up to a 12.5 ton family, even with the duct connectors moving around, it's still one family. And then all the way up to, a 23 ton unit, just another type. So what other cool features do we have in here? I'm going to replace this. Okay. So we have some hoods that are hosted to the articulated Cartesian arms, and those hoods essentially are tied to economizer functionality and power exhaust. So if we looked at edit type in here, so power exhaust is not checked. If we turned off economizer, what you'll see is that hood vanish. It's still there in the family, it's just not being used at the moment. So that's just one example of geometry hosted to the arms in addition to connectors. So in the constraints category, this is going to be very similar to other families. Electrical has their overrides, and the mechanical design parameters are here. We have a design airflow per cooling capacity value that's just used for reference, but wink wink nudge nudge, I could see that being used down the road for an auto sizing functionality. On any note, let's see what else we got in here. So demand control ventilation, that'll just update the schedules, minimum outside airflow and supply airflow. It's all going to be based upon connected to begin with. So let's see what we got. I have some loads that were just completed for this sample project. And we have rooftop unit 3 is what we're going to be working on. 1300-ish CFM, 4.1 ton load. So I'm going to end up placing a 5 ton unit, and then we'll go from there. And our outside air is a 185 CFM. All right, so Let's place a new instance. Okay. So we have our gas connector here and our waste connector out here, and then supply and return. All right, so let's, well, we'll get to the outside air in a little bit. Let's look at what we get to begin with. So just like that, placing the family down with a performance table, we are able to pull compressor, running load amps, quantities. We have a default value for motor power, which is returning motor full load amps from the NEC table. So just by placing this down, electrical is already getting a parent load, and we haven't done anything yet. I think that's pretty cool. These families, they're intended to be used for all different types of voltages and phases. So electrical would be responsible for going into the type down to electrical circuiting and updating this voltage and phase to whatever they're designing to. Okay, so I'm going to go to a 3D view, and here's our unit. We've added some really cool functionality with this unit. Some manufacturers in the past, they have placed multiple connectors on horizontal faces for different arrangements. That can end up just making it tougher to connect into. I'm going to raise this up. So we have a curb family there as well. Just wanted to make sure you saw that. So we have a magic button. The magic button right here is switching between horizontal or downflow configuration. This is actually a very complicated process. I'm just glad to see that it's working in the family. So just like that, clicking a box, and now we're able to move the discharge and inlet to the side of the unit with no additional connectors and no additional reference planes. Okay, in my case, I'm going to be going down with it. And now let's go back to plan view, and let's start making some connections. All right. So we have some supply ductwork already here. I'm going to move this, generally speaking, into the area. Now there's very few reference planes in this family, which is nice, so that'll make it easy to align it without having a million different reference planes. So we're going to move the unit over like that, and then we're going to move the unit up. So I have a gas pipe here. I know it's kind of silly, but I'm going to align the unit to that. All right. I'll just keep this off for a moment. All right, let's take this unit. And let's call this RTU 3. All right. So now we want to make some duct connections. I'm going to draw a duct down from this point. And let's go down to 10 feet. Another thing that we've done is we've rounded out nominal sizes for the ductwork. Cut sheets definitely don't indicate nominal duct sizes in most cases. And a lot of times manufacturers have just kept the connector, those fractions of sizes, which is just inconvenient for the user. So these are all rounded out for you guys, so you should enjoy that. And let's bring this down, and we'll just put something on the end of this. So I'm actually going to change this to a mitered elbow. Rectangular duct takeoff mitered elbow. All right, now I'm going to place something at the end here. This is a new family that we haven't talked about before, and let's hope I can find it now. Yes, it's a fitting. So if we want to place wire mesh over the end of something and still get airflow from that and be able to tag it, we can do that. So here's round wire mesh. We have rectangular wire mesh right there. So let's place that there and let's see what that's actually doing. Okay, that's our connect to existing tag. If we change that tag to be description, hey, we've got wire mesh called out on the plans without using a keynote. That's great. And we can also give this an airflow. So what was our loads again? Let's say we're going to end up at 1400 CFM. All right, we just propagated flow into that duct. Now we're going to make some connections to this duct here. Let's go to a section for that. So it looks like my 10 feet went down really low. Okay, let's make some connections here. Okay, and I'm going to cap this open end. All right, now that duct has 1400 CFM. Now we want to make our gas connection. So let's go look at this section. All right, there's our gas connection. What do you know? We've already got gas flow. So if we take this pipe, look at that, I already have gas flow and we haven't even picked fuel input yet. Okay, we'll move this back. All right, so very common situation for a rooftop unit. Wire mesh in the return air opening and then ducted supply. All right, let's go back to plan view. So we've already talked about we have full electrical loads for the electrical discipline to begin with, just by placing the unit. We've made our connections to the unit now. So now we're able to see that based upon our connected airflow, we're at 280 CFM per ton. This supply airflow, as discussed previously, is using the connected airflow unless we override that. So we can look at our mechanical flow here. So here's our two connected airflow streams. So we could override this or we could leave it. So let's say we wanted 300 CFM per ton. We could say equals 300 times 5 for a 5-ton unit. So we can update things that way. I'm going to keep the override at 0 for now. The outside airflow, well, we'll edit that later because I want to show you guys how to work this family and the schedules. So there we go. Family's placed, everything's connected, electrical has loads, everything has airflow, the gas system has a load. Let's look at some of the calculations now for the gas-fired heat exchanger. So cooling coils, we're not doing any calculations yet. Gas-fired heat exchanger. So because we have a performance table, we were able to include the different, the 3 heat settings offered from Carrier's line. So in this case, these are all the values that we're calculating or pulling from the performance table. The efficiency rate here is being used to calculate capacity, And this capacity value right here and airflow is being used to calculate the discharge air temperature. So right now we're at 116 degrees Fahrenheit. If this 55 degrees entering is accurate, well, which it's not. So this is based upon 1324, but right now our mixed air temp is 53.2. So I guess it's pretty close. All right. So we could rebalance the diffusers to get down to the exact load. I'm going to keep it how it is right now. So with a 55 degree entering air temperature, the medium heat setting on this given unit is 116 degrees. Let's see what the low heat option looks like. 93 degrees. I like that one better. We have some heating coil parameters in here, and that's really just for the time being because I see this family being used for heat pumps and other rooftop equipment with electric heat. And then all of these dimensions are basically used for the arms. So you can ignore those. We've already applied the space identity overrides, so this will show up as roof in the schedule. And that's probably all we need to discuss at the moment. All right, let's look at our gas riser diagram. Okay, here's our gas riser diagram. So here's the unit we just placed. We can tag this. Okay, and I'm going to use this tag as the gas load type. There we go, so 72 MBH. You know, and this is all propagating downstream now. So let's tag this pipe here. All right. So if we did update this gas load, you know, this would inevitably update. I'm going to... All right, let's go take a look at the schedule now. And keep in mind, we've done very little work so far. Let's see what's left in the schedule. So if we go to our HVAC schedule, and here we are. So this schedule has been designed and optimized for this rooftop unit family. Lots of things that ended up being options and notes before, we ended up making parameters so users could just check yes or no, like economizer, hot gas reheat, power exhaust. So basically we're left with filling in the rest of this information. Let's go to the schedule. So we have a supply airflow, and that is a formula-based value. So if you want to edit that, you would have to go to that design airflow schedule. And maybe I'll pull that up just as a fresh reminder. So under M_design airflow and equipment. So here's the connected values, here's the scheduled values, and here's the overrides. So for rooftop unit 3, if we wanted to override it, we could edit this value. Airflow in components now is a place where we could edit the outside air value. I believe we needed 180 CFM, 185 for this unit, not that much. So that's 13% of our airflow. So you'll see the gas-fired heat exchanger is using that airflow as well. Okay, so now back in this schedule, there's just a few things left to update. We could update our external static pressure. This is going to be very minimal. So let's go 0.5. You know, drive belt. So these fans are the default standard static fans. If you need to increase it from there, you could do that. I don't believe power exhaust is available for this size unit. We've got some capacities that we could fill in, and then essentially entering our mixed air temperatures. So hot gas reheat, we could include that as an option. Here's our burner loads, and basically all of this is already filled in. We talked about editing the fuel properties for the entire project in one place on that cover sheet. Low ambient kit, so we could schedule the charge. We could indicate, I guess we can't indicate a SEER value. That parameter is not in the family, which I should fix. We would edit our ER value. Whoops. And then you can choose to include a condenser coil protection or not. So just like that, it's real easy to use this rooftop unit family, place it and schedule it. This is really just the beginning of a lot of these performance-based families. I hope you guys see the huge advantage of these, because I want to get many more manufacturers involved, and many more types of families. So I'd love to hear your feedback, and I hope you guys enjoy the content.